Hello everyone, welcome to my channel Essentials of Electronics. In today's video, we will be discussing the types of basic voltage regulator circuits. What is the voltage regulation? Yes, the process of getting a constant output is called regulating the voltage. In regulation, we have two types by which you could regulate the voltage. One is line regulation, the other one is load regulation. Line regulation is the variation of input voltage and output voltage. Yes, Vn is taken on x-axis and V naught is taken on y-axis. As the input voltage varies, the output voltage will also vary and maintain constant. Number two, load regulation. Load regulation is drawn with respect to two parameters, V naught and I naught. Yes, V naught is taken on y-axis and I naught is taken on y-axis. As the load current varies, V naught will be constant. Series voltage regulator and the shunt voltage regulator are the two type of regulator devices which maintains the output voltage of a power supply constant at maximum possible extents. A series voltage regulator, the regulator a control element which is mounted within a series of output voltage and input voltage is known as series voltage regulator. I will now draw the circuit diagram of a series voltage regulator using a BJT. It's the source resistance RS Q1 and input voltage Vin. It's a Zener diode. The output voltage is connected across. So the total output voltage. How will this operate? With variations in input voltage, when the input voltage is fed in, the Zener diode is connected in a reverse bias manner. So the property of Zener diode is during positive cycle, the voltage increases, the current increases and the voltage. At a particular point, the voltage will increase above a threshold voltage. But in a shunt regulator, the Zener diode is connected in a manner. The anode of the Zener diode is connected to the base of the transistor. The input voltage Vin, source resistance Is current flows into the circuit. Vz is the voltage across the Zener. Iz is the current in the circuit. Ib is the base voltage and Vb is the base emitter voltage. So on varying the output load resistor, V naught is equal to Vz plus Vbe. The output voltage is equal to the voltage drop across base emitter and the Zener voltage. V naught is equal to Vz plus Vbe. So this is a shunt regulator circuit. So based on the transistor shunt regulator circuit is formed by connecting a resistor in series with the input and a transistor whose base and collector are connected by a Zener diode that regulates both in parallel with the load. Actually, when Vin increases, the current In also increases. This current when flows through RS causes a voltage drop DS across the series resistor, which also gets increased in Vn. But this makes V naught to decrease. Now this decrease in V naught compensates. This decrease in V naught compensates the initial increase, maintaining it to be constant. Hence, V naught is always maintained constant. If the load resistance decreases, the current through the base of the transistor decreases. As a result, lesser collector current will be shunted. Therefore, the load current becomes larger, thereby maintaining the regulated voltage across the load. Reverse happens should the load resistance be increased. Thank you.